Today's video will give a live demonstration of the three message passing design patterns. Hello, I'm James Helfrich. There are four different ways which we can pass a command from one part of the program to another. The first, the default, is direct invocation, just call the function. The second, delegate invocation, pass a function pointer. The third, encapsulated invocation, and the fourth, the interpreter. This video will demonstrate all four of these using the C++ programming language. Okay, the first thing we're going to do is we're going to demonstrate direct invocation. In other words, straight up function calling. Okay, let's take a look what we did here. We have a position X and Y, 10, 20. We're going to report our initial position. Then we're going to move up, move left, and then report our new position. And so every one of my functions here is going to either move my Y or move my X by a given amount, by just one slot. So I'm going to directly call these functions, and of course, when I run this, it's going to work exactly the way I expect. There's nothing really subtle about this code. We've done direct invocation like this several times before. Okay, now the question is, how do I turn this to a delegate? And the answer is I got to turn this command, move up, down, left, or right, into a function pointer. Okay, let's take a look at what we did here. We have a awful type definition, which is a pointer to a function. So the return type of the function is a void, It can take two parameters, x and y by reference, and the new data type I created is a move, which is a function pointer. So now I'm going to create a variable called pfn move left, and right now it's going to be move left, and now I can execute the function pointer. So when I run this code, I expect to have just a left move. And sure enough, so it's not really that interesting. What we really want to do is have one part of the code create the collection of orders and a separate part of the code execute the orders. To do this, I'm going to put all the orders in a vector. Okay, let's take a look at what we did here. First of all, I have a function called commander, which is going to push back a move left, up, left, up, up. It's going to push back 7 different orders into my vector of move, and it's going to return them. And then I have a separate function called executor, which is going to take the collection of orders as well as the context. In this case, I want to move X and Y, and I'm going to execute them one at a time. This allows me to separate the creation of the order from the execution of the order, which means they do not have to happen synchronously. Let's run the code to make sure it works as we expect. And sure enough, I did move left 3 positions and up 4 positions. This is the delegate design pattern. I'm passing a function pointer to another function, another part of the program. I can also use a similar mechanism to store undo of the different actions I've done, or delay execution for later, or a bunch of different things. Now, let's work on the encapsulated invocation. Okay, let's take a look at what we did here. The first thing I did is I created a base class which contains an order. Now, instead of having to pass parameters like I did before, the cool thing about encapsulated invocation is the context goes with us. In other words, my X and Y. I had to have a pointer to X and pointer to Y, but that's an unimportant detail. My constructor is going to save those member variables. This is a pure virtual function, execute, therefore this is an abstract class. So my move left is going to be a type of order, and I'm going to move left. My move right will move right, my move up, and of course my move down. Now, the important thing to note here is now when I create the order also has the context, in this case, my position X and Y. So I'm going to create a new move left, move up, left, up object. And then I'm going to return it. And then when I execute it, the executor is not going to have to take the context because the orders already have it with it. So therefore, I can walk through and execute them all in turn. And when I run the code, we're going to see that I got exactly the same results I had with the delegate. The difference is the order is now self-contained. It has the context as well. And that's the big advantage over encapsulated invocation. The final type of command passing is called the interpreter. And here I need to come up with my own command language. Now, my command language is usually going to be text. And what I want to do is be able to pass the text and have that interpreted as an order to be executed. And this allows me to pass a command between two processes that are in different memory spaces. So from a client to a server, because I can't pass a pointer from a client to a server because that pointer is going to mean something different in a different memory space. So I got to encapsulate in a text. Okay, let's take a look at what we did here. First of all, my commander is going to pass a text order. There's no pointers, there's no classes, there's no objects involved here. I'm going to move left, move up, move up, move left, move left, move up, move up. Now note, I can easily put this into a TCP/IP packet and send this over the wire. There's no pointers involved, super easy to do. And then my executor is going to take this string and I'm going to break it up into the order, move most of the time, hopefully, if not, I'll have an error, and then the direction, hopefully up, down, left, or right. And then I will execute move up, move down, move left, or right according to my position here. So now I'm going to get my order from my commander and I'm going to pass it to the executor. And when I run it, I'm going to get exactly the same results that I had before. The thing to note about this is both the commander and the executor have to have a shared understanding of what this language is. This is called document coupling. We really don't want to have many functions within our program have document coupling because the interface is so complex. However, when we're passing over the wire from the client to the server, we really don't have an option. Now, there are better ways I could have done this. If, else, if, else, if. There's got to be a better way. Let's try something new here. Okay, what I did here is I created a map where string is the key and the value is the move function pointer, the delegate. Remember that? We're going to combine our delegate with our interpreter. And now I'll say up is move up, down is move down, left is move left, right is move right. And now all I have to say is move of direction and then pass the parameters X and Y, and it works exactly the same. You can learn more about the delegate invocation, the encapsulated invocation, and the interpreter in the command passing chapter of the software design textbook.